The area of this rectangle is 40 meters squared. Could we calculate the value of x? Pause the video now to have a think about that. So in this instance, the area is x times x plus 6, so x squared plus 6x. And that would equal 40. One way of doing this, trial and error, possibly. Probably a bit difficult because x appears twice in this. We can manipulate it so there's only one x, so to make it easier. One way you've seen this done already probably is by getting everything on the left-hand side and factorizing. But another way we can do this is manipulate the expression so that we only have one x. We can do that like this. If we think about x times x plus 6, we can break our rectangle down into this shape. And we can split that 6 up into two 3s. And if I move one of those green areas underneath, you can see that what we have here is almost a complete square with just that white bit missing. So the area of the whole square is going to be x plus 3 squared. So the difference between the whole square and the area that we actually want to find out, the actual area here, is just the white box. We only want the shaded area, so we need to subtract the white area. So the white area in this case is 9. So what we're saying then is that x squared plus 6x equals 40 is the same as x plus 3 all squared take away 9 equals 40. What we've done is we've replaced x squared plus 6x with x plus 3 all squared take away 9, just written it in a different way, using the diagram of the square rather than the rectangle. And we could solve this, like I said on the previous slide, using without using a calculator. We can add 9 to both sides to get x plus 3 squared is 49. We have to be careful at this point when we square root both sides, because something squared is 49, that something could be positive or negative. So x plus 3 is equal to positive 7 or negative 7. The square root of the left-hand side, x plus 3, is equal to plus or minus the square root of 49, so plus or minus 7. So at two different solutions, but the length must be positive. So x has to equal 4 in this case. It doesn't always have to be that we need a positive answer. It could have been, if a negative answer was allowed, we would have had either x plus 3 equals negative 7 or x plus 3 is positive 7. If the negative 7 was allowed, then we would have had an answer of negative 10. And obviously this isn't valid in this case. Any answer in this case? In meters. This process is called completing the square. And we can use it on quadratic equations to make them symmetrical, so with 1x, and it makes it easier to answer.